Hello all, in this particular video, I'll be talking about the a priori algorithm. As we have discussed in the class, a priori algorithm uses frequent item sets. We have to find the frequent item sets, and with the help of those frequent item sets, we have to generate association rules. Okay, so this particular process we will adopt in our a priori algorithm. And again, I will repeat this as I have told in the class, that what property will it follow in the algorithm? The property that it follows is a subset of a frequent item set must also be a frequent item set. If you break a item set into smaller component, then that smaller part of it, that sub part of the larger frequent item set, is also an a priori algorithm. Okay, so with that, we start off with a priori algorithm. Again, there are two steps here: join step and prune step. Okay, so we'll straight away go to the example that we were discussing. So here is the example, and this is the data set given to us. And as I mentioned, we will pick up the first item. The first step is to find C1. Okay, to find our C1 candidate set, and we will start with k is equal to 1. The size to start off of the item set is k is equal to 1. So we will list all the item sets. So here if you see, this is the list of item sets present in the data set, and in the next column we will write down the count, how many times it has occurred in this data set. Okay, so that is the first task to have item set, one item set, and to list down the support count. After that, okay, we have to generate the candidates, compare candidate support count with minimum support count. Okay, now we have to check and do filtering if possible. All right, and that time we will need what is known as minimum support count. Okay, so here minimum support count is 2. So we'll choose only those item sets in which the count is either equal to 2 or greater than 2. Okay, so fortunately here all the values are higher or equal. All right, so that is why here it will remain the same. From when you go to C1 to L1, it will remain the same. Okay, so all the item sets are present in our candidate set. So next scan, we will do what? We will generate C2 from our L1. That is what we discussed in the join step also. Okay, a set of candidate set k item set LK is generated from LK minus 1. Okay, we get L2 from L1, and that is by joining LK minus 1 with itself. Okay, with itself. So this will be joined with L1 again. Okay, and then I told you that it will be joined with itself, I1, I2, I3, I4 and I5. Okay, so it will be joined, and after that we get these combination, that is our C2. Okay, and then in C2 we know we have to write the count also, support count. So we list down the numbers here, that is how many times this particular combination has occurred, occurrence frequency in other words. All right, so for all the combinations that we have generated, we are going to list down the count. Okay, and then again from C1 we go to L1. We had gone to L1, so here also from C2 we go to L2, and while going to L2 we have to do pruning. Okay, we have to select. We will only select those item sets k is equal to 2 in which it's higher than the mean sub, higher or equal. Okay, 2. So we'll select that, and you see that we are selecting all those item sets from here, pair of item set, that is the whose support count is either 2 or greater than 2. Okay, so like that. Now from L2 we have to go to C3, L3 we have to generate, and that is again L2 join L2. Okay, now here was where we could not go ahead in the class. Okay, so listen to this very carefully. How do we get C3 by joining L2 to L2? Okay, so this is I have this slide here where I have given it very nicely. Okay, so this is how the C3 is generated. We have to join L2 with L2. Okay, so this is all the values that are there, and it is joined with itself, same values. Now how to get the resultant k is equal to 3 item set, how to get the output, okay, after joining. So here, just remember, first of all, you have to pick this. Okay, pick the first set and combine it with the remaining. So I1, this is the group. Okay, so what I'm going to do is pick up this item and combine it with the next, actually from this, with the next item having I1 in front. Okay, so that's what I've written here. With I1 in front, I'm just in this particular I1 range. Okay, so the first I1 is picked up and combined with the remaining I1s, starting with I1s. So with I1 in front, we have to now combine with what's the remaining ones. Then if you leave if you just see the I1 series, you will see I2, I3 and I5. Okay, so we will first do that combination, joining. And by doing so, we will get, see, I1 in front. So I1, then next, here I've written it nicely. So I1 is in front. So the next combination is I2 and I3. All right. Then I1 in front, 2, 3 is already combined. Then I'm going to combine 2 and 5. So 2 and 5. Okay. And the last combination is what? I1 you pick up. Next is 2 and 3 is combined. 2 and 5 is combined. Remaining is 3 and 5. That's the last combination. So we get 3 and 5. All right. So that is how we are going to get the first 3 values, combinations. Keeping I1 in front, form the combinations with I2, I3 and I5. I2, I3 and I5. And this is what we get. Similarly, okay, so the next, the first step of join of I1 series is done. Then same thing we do with I2, this one. Sets starting with I2. All right, so we start with I2 and then we start combine it with this. So how will you remember? With I2 in front. See, it's very easy to remember. With I2 in front, that means the first lot, combination with I3, I4 and I3, I4 and I5. So again, we do the same thing. First we start off with I2, we keep I3, I4 like this. In the second slot, in the second combination, in I2 series, we put I3 and then we combine it with 5. Okay, and the last is I2, I4 and I5. So like that. That is this series combined with this series. Okay, always remember there are chances of confusion. Remember like this. With I1 in front, form the combinations of I2, I3 and I5. And with I12 in front for the next set, form the combinations with I3, I4 and I5. Okay, so we are going to get 6 possible outcomes. 6 outcomes we are getting. I have listed it here. I have drawn it also. I have done some color coding also to make it more clear. Okay, because here chances of confusion are there. All right. So I hope that is clear. So we go back. So this is like 6 combinations we are getting out of it. All right. So now what do we do with these combinations? So here from that combination, see, I've listed these combinations also. Okay, so see, I1 3 series where I1 is starting with I1 and 3 combinations starting with I2. That same thing. All right, so I've pasted it here. So from this, we have to now do the selection, the filtering from C3. Okay, or rather, which combinations do we take? Scan D for count of each item. How many times it has occurred? Okay, so we'll take that. And we see from all these possible outcomes, only 2 outcomes are actually occurring in the data sets. Okay, and you can check that it is I1, I2, I3. I1, I2, I3 has occurred 2 times. So I'm listing that 2 times. Similarly, check for others. I1, I2, I5. Okay, so it is here and here 2 times. But for other combinations, okay, there is no occurrence. Okay, though we have joined those and got the combination, but doesn't mean that we are going to include all the possible combination outcomes. Okay, we have to include only those in which there is some occurrence, isn't it? There is some count. But if it is not existing in data set, then why do we list it? We should not list it. So when we go through all and check for its occurrence, we see that only this, the above 2 case is there. You can verify that. Okay, so that is 2 and 2. And again, we have to now do pruning. Okay, select from C3 to L3 like we have done from here to here. So what do we do here? Now both of them qualify because it is equal to 2. So these, and already the number has gone down. So these are the 2 K3 item sets which gets to be present in our L3, I1, I2, I3 and I1, I2, I5. Okay, and one more thing you have to verify. Sometimes it's not holding here, but for some examples it will be there. That property, a priori property. Okay, that means if you break this, just check if you break this, let's say I1 and I2. So we should also make sure that if we are breaking it, even the subparts are frequent. Okay, their frequency is higher than support count. So let's check I1, I2 higher, so qualifies. Okay, I2, I3, I2, I3 also 4, so it qualifies. All right, then I1, I3 is done. I2, I3, then I1, I3 also you can check 4. So all the 3 paths 4, 4, 4, okay, they are frequent. If you see sometimes that after breaking it, in our examples you may find it to be true, after breaking it the subpart is not frequent, then we cannot keep it here. Okay, so similarly for the next one also you can check it, break it and check for the frequency. It has to be higher than the it has to qualify. Okay, it has to be higher or equal than the support count. So that happens for I2, I1, I2, I5. Okay, I1, I2, I2, I5 and I1, I5. Okay, they qualify. So it is fully frequent item set. Even after breaking, you have seen that it still remain frequent. Okay, frequent. So that is the value of L3. Now what after that? Okay, so after L3 also we should go for the next run. Now in the next one, what is happening? Where are we? Okay. The transaction in D are scanned in order to determine consisting of those candidate 3 item set. Okay. Then next, okay. So this is the step explanation here. Based on the a priori property, all the subsets of frequent item set must also be frequent, and that is actually applicable on those two. Okay, a priori property. Okay, so we select those having okay, so here is that last step. All right, so the algorithm uses now from L3 we have to go further, try to get C4. Okay, if possible. So in order to get C4 we have to do this L3 into L3, although the joint result, so we'll have an item set of size 4, although the join results in, so here we have everything together, I1, I2, I3, 5, all of them together. Okay, uh, this item set is pruned because its subset I2, I3, I5 is not frequent. So listen to this very carefully. All right, now we have this combination. All right, after joining the two parts, this one, if you join this with this, C3 into L3 into L3. Okay, so after joining you will get this set I1, I2, I3 and I5. Okay, 4 is not there. See, 4 is nowhere here, so it will not be listed here. We will only do join of C3 with C3, L3 with L3 rather. Okay, so we will get this. All the items are listed. All right, so one combination for that. But if we look carefully, if we break this up, okay, because you have to check after breaking also. After breaking, we see that there are items like I2, I3, I5. If you check this I2, I3, I5, okay, it is not frequent. The count is less than 2. I3, I2, I3, I5, if you break that part is not frequent. And because it is not frequent, it doesn't satisfy a priori property. Okay, so this outcome, this result doesn't satisfy, and that means that nothing is going to be filtered out. C4 is equal to 5. 5 means empty, and that is the in signal where the algorithm terminates. Okay, so this is the step. If you can't go further, okay, if you don't get an item set which is having a priori property, that is the indication that then we have to stop. Okay, so there's nothing to go ahead. So that is how algorithm will stop. And what do we have in our hands? We have I1, I2, I3 and I1, I2, I5. Okay, in C3, and that is, these are the resultant, these are the result. Okay, these are the resultant frequent sets, and association rule will be formed with the help of these frequent item sets. Okay, so that is how algorithm works. I hope it is clear now. The combination part, okay, please carefully observe everything, listen to the video again, and this I hope this how to generate the outcome, okay, how we are stopping in L3, that is clear. Okay, thank you class.